Okay guys, so here it's a short manual how to start our labs. You will need to configure the machines. In particular, first you need to enable your Windows to be operating with your development board. It's not so easy because this driver here is very unusual. This driver is using a COM port over USB, and this board is special. Over a single USB link, over a single USB cable, you have two COM ports. The first is for programming and the second is the JTAG debugger integrated. So it's still a nice solution, but it requires you to have a special driver that is not embedded natively in Windows, unfortunately. So in this case, I'm gonna simulate here just to my virtual machine. You will have it on the physical ones. In case your Windows is already configured, you should take a look into the device manager, and then instantly you will see that the two COM ports are installed. In my case, I don't have those drivers installed. Perhaps it's the same situation with you. So in that case, just have a look to the internet. Take a browser, open it, and type here something like that. Windows 10. You may write x64 or choose it later. ESP32 WROVER driver. And then it will just take you into the Espressif website. And from that stuff, you need to find out the ESP WROVER stuff. So it's this development board you're using. If you go a little bit down, you will see here FTDI virtual COM port drivers. So it's all stated here how to get it working for different operating systems. So this page is generally helpful. Whenever you start on Windows, perhaps you want to start from here. So you will just go into this FTDI driver, and then just have a look into the Windows section. You will need this one. Yep. Just click it here, save, and when you're done, have a look. It's a zip file, so you need to extract it. It's a certified Windows driver, shouldn't be any problems with the certificates or whatever it is. But you see there's no installer here, so instead of what you do is, if your Windows didn't install it yet, it's pretty possible. So in that case, you may just right click it and say, okay, update driver, and browse my computer, and then just go through the number of folders when you have downloaded it. So far I downloaded it to the downloads, so it should be in my downloads folder, then expand it to this qualified stuff, click OK, next, and so on. Well, I see that my Windows was somehow able to find it out with ease, but anyway, if yours is not, just follow this instruction and then you will be safe. As you see, we have two COM ports. Just to be sure, I will show you that they will disappear when I remove this device. I'm removing this virtual. You can plug out your cable. I'm just removing that. There are no COM ports at the moment. When I just will plug it in, then it appears back and installs drivers, this time automatically. So you see there are two COM ports. The first is COM port 3 and the second is COM port 4. The numbers can vary, depends on what you've been connecting to your computer, so there may be different numbers. In any case, you shouldn't have any exclamation marks here. If you do, just update the driver the way I have been showing to you previously. Just go through the to this folder here and let it pull those drivers and install them for you. That always helps. So this is the step number 1. And at this stage you should be able to be talking to your ESP chip, but still we don't have an appropriate tool. So the next step is we need to install Visual Studio Code. And the Visual Studio Code is just an open source source code editor with many integrated features. The one I like the most is the IntelliCode, IntelliSense, that is makes a highlight for your syntax. It's so nice and so great when working with this, comparing, for example, with the Arduino IDE. Well, you still can use Arduino IDE, but anyway, it's like a different quality when programming in this one. So we just wait, and then we have it done. And once our file is downloaded, then we just simply follow the installer. It's not very big, but it may take a minute to install it. Visual Studio itself is just a code editor, and it won't bring you any development tools. So we need two things. First is a development toolkit for Expressive for ESP32. And the second is a kind of proxy. Here we will choose a PlatformIO. It's a kind of the manager. Well, you can think my other videos on that. PlatformIO is really great because it handles all those complex tasks like configuration of the compilation toolchain, library management, and so on and so on. So all you need to do is just to go to the extension, this icon with the components here, and then you type PlatformIO. And it's this PlatformIO IDE. So click it. You see this ant icon. And the installation also may take a while. This is great because it's cross-platform. It's not only dedicated to Expressive or any other thing. It enables you to develop for any board. So when you're done, then you may need to reinstall restart the Visual Studio, but it installs a number of dependencies, like you could see, and in a minute it was a debugger. So I suggest you to close the Studio Code and open it again. Sometimes it asks to do it manually, sometimes automatically, so in any case you had better install it and restart after install. Now it starts, and after a while you will see here PlatformIO extension installing at the bottom. This is the core part, so the PlatformIO is not only a part that integrates with the Visual Studio Code, but also the part that goes under the hood, and it installs Python for you if you don't have one already, and a number of other dependencies, so you may need to follow the installer and click and agree for. It's strongly machine and your history of operating system dependent. Also on the platform you use is different for Windows, slightly different for Linux and Mac OS, but still it's all guided, so it's written. So when you're done with installing, restart Visual Studio Code, and when you boot it, when it starts, it first automatically checks your installation whether it's okay. Maybe quicker or slower. My virtual machine is pretty slow here, so give it some time. And then it should automatically pop up a welcome page for PlatformIO. In case it didn't, just click this home icon here on this purple bottom bar. Now, this is our home page, and now this PlatformIO is empty. We cannot create the project because we don't have a platforms. So we switch into the platform, then embedded. As you see, you can have even desktop development here, like in C++ or C# or whatever else. But here we focus on this ESP32. It's from Expressive. That's the correct one, ESP32. Just click it. Click it, install, and that will take a lot of time because it needs to pull all the development toolchain for Arduino, for Espressif IDF, and two others like Pumbaa and Simba. Whatever the other two mean, we are focusing on this Arduino section. And those labs, you may also just jump into the Espressif IDF if you are willing to, but we'll use Arduino IDE. Now, there should be an announcement when it's ready. Platform has been successfully installed, so click OK. And then, in the installed section, it should be visible for you. You will also find a notification about the updates automatically, so when you start PlatformIO and the Visual Studio Code, and that will let you know if there's an update for the Espressif. Highlight the information here with the number of updates. It's usually if you have single framework, then it's like one update, and you can update it from within here. You don't need to do it manually, somehow extended. So it's all integrated. So that was the first thing. And the second thing, before we start development, it's libraries. So we'll need a number of libraries, and they strongly depend on what you want to do, what kind of the hardware you are interfacing. But for sure, in case of this ESP32 development board, there is an LCD display. So just to install this library, go to Libraries, then this registry, and type WROVER. And that will find you WROVER Kit LCD. Click the library, install it. And you will have a notification instantly that has been installed. So here we are. Now, if you jump back into the home, we create the first very elementary project. It's gonna be a Hello World application. Let me type the name here, like an ESP32 Hello World. The scenario is as follows. We are going to use serial port to type periodically in the loop section Hello World every 2 or 5 seconds, whatever we choose. So here we need to find out the WROVER toolkit. Yeah. And the framework is Arduino. Here you see it's also this Espressif IDF, but we use Arduino. You can change the location of the directory. Well, generally the PlatformIO project is nothing more than just a folder, and within this folder you will find PlatformIO.ini file that specifies this development board, eventually some extra settings, libraries you use, and so on and so on. So this is what the creator is, the project wiser is doing right now for you. Have no idea why it takes so much time, but anyway, give it a minute. When the project is ready, you will see it here on the left-hand side in the folders section. Now, once your project is ready, it will create automatically a structure of folders, and you will find the main CPP file in the source folder, as usually for the C projects. Please note, those libraries that are installed globally, they not necessarily need to be put here. You can just refer them globally. If you want to add your own libraries to your own project, like for example, you create your own code and make encapsulated in the library, then you put header files into include folder and your CPP code into lib folder. Now, this is what was generated for you. Mind, they put here like an include Arduino.h to make a compatibility regarding the names of the GPIO ports, to use the same scenario like you use in case of Arduino IDE. However, in this very example, I'm not going to use any special GPIOs here because it's just a hello world. So my code simply looks like that. One hint, we will connect using serial monitor that is integrated into this PlatformIO and the Visual Studio Code. So the default is 9600. That's a default speed for communication on the serial over USB port. So you had better change it here. Eventually, you can change it in the configuration. Now, the configuration is here in this PlatformIO file. If you open it up, you will see there's a section saying, okay, it's an ESP32 WROVER kit, and the platform is ESP32, and the board is ESP32 WROVER kit. This, and the framework is Arduino. Of course, there's a number of other important settings here that you will use, but at this moment, we'll keep it very simple. Let's give it a try to compile. So here's a compile, like a build your code, and here it's upload your code into the board. Of course, one is pulling another. If I click upload right now, it will first compile. There's a terminal showing the progress, so we'll have any information on the errors here. As you see, it was missing some tools. So it's also automatically pulling whatever it needs, actually. I barely need to do anything manually here in the solution. It's really, really automated, and it's a pretty good job. I'm talking about the PlatformIO, so I like it very much. Now, as you see, it's trying to connect right now. The problem is that the COM3, perhaps, it's not a COM port for uploading the code, but it's COM port for debugging. Unfortunately, that cannot be automatically discovered for you. So you may want to break this task right now. For example, clicking Ctrl and C, as aborted by user. And right now you need to tell the PlatformIO that it should use COM4. Just for reference and recalling, I have two COM ports here. It's COM3 and COM4. So you can type it manually in the PlatformIO, but there is a simpler way. You just go into the projects, and then you make a configure, and then you can just start typing a new option that will make you a helpful hint. So in this case, I'm going to use a setting called upload port. And the value for this upload port is COM4. As you see, I not necessarily need to type anything here. Just remember to type save. And that will simply modify your PlatformIO, just adding you this command here. So once you are familiar with this command, you can edit PlatformIO directly in this section. Now let's go to our main C++ code and let's try to upload it again. By the way, the serial monitor here is this plug icon on the bar at the bottom. So later on, when it uploads successfully and it starts your code, you can connect anytime to that one. But please remember, it's not like in the case of the Arduino IDE that the code execution is waiting for connecting the serial port. Unfortunately, not here. Here it starts immediately, so if you connect later on, you will jump into the middle of that. So if you have something that you want to observe in the setup section, the correct order is as follows. You first compile and upload, then you connect serial monitor, and you manually reset through the reset button your board. As you see, it's writing right now. So COM4 in my case was the correct one to upload the code. And I'm just connecting with this one. Now, in case of this particular platform, it will also may ask you which COM port actually you want to connect to. I'm gonna reset my board now. As you see, it didn't connect, so I guess it's using this COM3 instead of COM4. So sometimes it asks. As you see, you can just type on Ctrl-T here. Doesn't help much actually at the moment. But the simplest is to tell it that you do want to use it anytime. So you know it's same port as you compile and upload. So in this case, you go to the project again, click the configuration, and then you type monitor port. And you tell it it's again COM4, as in case of the upload port. Save it. Then you upload it again. And as you see, we have connected to COM4 and this loop here. Every second it sends hello world. It means your environment is pretty well configured and you have capabilities to compile correctly and upload your code and monitor what's going on there. Thank you.